Yo, what's up? Good morning. Let's see if we can make the Terraform work today as well. We're gonna go back to the bottom of it. So the underlying system is a bit reworked. We now have some padding to each terrain data texture. Maybe not all of them actually, or I think we will have. So translating the world coordinates to texture coordinates and different texture coordinates if we're changing multiple textures at the same time is a little bit complicated to say the least. I'm gonna see if we can... Let's see if I can make a figure of this, and hopefully that will help us a bit on the way. This overlap is a bit crazy. So let's see if we can make it make sense. Yo, what's up, Harukanan? So if we have a texture that is 4 times 4, that's the actual data, then it's actually 7 times 7. So let's start with that one. Do I want to draw... Yeah, maybe it would be nice to have the actual mesh here as well. 1, 2, 3, 4, 5. Do we have... Okay, we have overlap there. That's a bit weird. We can probably do it like this. Fuck, I want to visualize this overlap here. We can actually probably do it like this instead. I hope. Opacity, there we go. Or I guess we could offset it. One pixel is a bit too much. There we go. Do it like this. Okay, so this is the overlap we're looking at, I think. Yeah, we have an overlap of 2 pixels. I don't know how visible this is. Something like this. Um, x7 texture size. 1.5. Do we actually have 2 pixel overlap? Nah. Or this one has. Oh, we actually have 2 pixel overlap, right? I'm pretty sure. It's something like this. Fucking hard to understand figure, but we can probably work with this. So the different grid, we have orange, pink, blue, green. Those are the 4 textures we have, underlying data textures. The dotted white line is the actual terrain we see in game. So we can see here, but I want to visualize it a little bit differently. Because it's actually located at the center of pixels. But how do I get this to work with... Did I screw up? Which actually makes me want to... Probably want to put it... Yeah, okay, we might actually want to do this. Oh, I fucked up. But can you group these in some way? Group, yes you can. Okay, let's do this. Let's go with some opacity as well. And then we want to do group. Okay, beautiful. Okay, okay, that's great. The more you know, the more you know. Oh, okay, I get it. Okay, that's great. So let's do ungroup. $100 group, and then we can change this one. Style opacity 30. Okay, we cannot. Or if I change one here, will they all change? No. Yo, what's up, Cynic? Okay, that's annoying. Ah! I don't understand this tool at all. Sick today, that's why I have time to join this early. Appreciate it. Hope you get better, feel better soon, man. I don't want to fill them, I want to add a line. But then we just get one. This is a group. Copy style. Are you serious? Okay, you know what? I think we're gonna have to do it like this. Ungroup. And we take all of them and we change the style. White. Opacity. We change the color of them. And then we group them. There we go. What opacity do we have? 50%. Okay, great. Let's just create 3 of these. But then we're gonna have to do ungroup. Change this one to pink. Group. That's not what I want to do. That's not what I want to do. Was it you who was playing Arc Raiders? No, unfortunately I haven't tried it. It looks pretty good though. And I wanted to ask you how you enjoyed the quest since last time we spoke. And then we group this shit. Okay, beautiful, here we go. Oh, quest is fucking amazing, nice. What did you play? What did you try? What did you do with it? So here we have our underlying textures. Have I screwed up? 1, 2, 3, 4, 5. No, I don't think so. And then we position them like this, I think. This is the overlap we have. I'm pretty sure. No joke, I fucking screamed by helvete when I tried mixed reality. Sick. Mixed reality. Oh yeah, so that's like projecting AR stuff onto the reality, yeah. First encounters, nice. I'm gonna have to check it out, although I don't have a VR headset, but I still enjoy watching the tech. Yo, what's up, Neozoid? What is this program? Just draw.io. It's beautiful to do weird figures and stuff, I think. I started using it when we were doing UML diagrams. Don't use it for that as much anymore. Let's delete this one. Let's start a new one. And then we go from the middle to here, I think. And then I want to... But that's not entirely true. Why am I having such a hard time getting this to make sense? Sent a nice video on Discord you can check later. Will do, will do. Actually, to make this make sense in my head, we're gonna do this. We're gonna remove this one, we're gonna remove this one, and we're gonna remove this one. Okay, so if we have a mesh placed on this texture, the mesh is pretty much like this. We don't want to fill this one. Fuck, do we have even more overlap? Maybe we do. Maybe it's even like that. Yeah, this is it. That explains it. Okay. Can we bring this one to the front as well? To front. To front, to front, to front. Bring forward. To back, to back, to back, to back. Is this visible? Okay, something like this. A student girlfriend was playing more VR than me now. She loves Beat Saber as she's an old dancer. Oh, nice. Beat Saber is a game I've heard so much about. A lot of people seems to enjoy it a lot. Never played it. Okay, so now we have spent a good amount of time on doing a figure that unfortunately doesn't look that great, right? I'm still annoyed that this one seems to be behind stuff here when it really shouldn't. Is that because... fuck it. So we have 4 7x7 textures underneath everything. Each of those textures has 1 full pixel of padding in each direction. So top, bottom, left, right. And we have that because we want to have access to neighboring data to do proper normals. Still don't know if this is the best way to do it, but it's the best one we have tried so far. But Cynic, by the way, have you tried Arc Raiders? It looks pretty damn good. Like, I want to try a extraction shooter. I had high hopes for Marathon because I think the art style of Marathon is insane. Like, it's the coolest art style I've seen in a long while. But unfortunately, the gameplay seems to be quite lackluster. Okay, so we have 1 blue texture, we have 1 pink, we have 1 orange, we have 1 green. And then we have 4 patches here. And we need to transform. What we have is... oh, one of these, I like it. What we have so far is... oh no, we're gonna do it like this. We do it like this. And this right here is our global UV between 0 and 1. And then we have Neozoid, what are you doing? We're gonna convert world space coordinate to UV space coordinates or texture space coordinates, but we need to take into account a lot of padding, pixel overlap, and stuff like that. It's basically, we're gonna do some terraforming on the GPU or some texture alteration on the GPU. So we need to get this right. And I want to have a nice figure for later on when and if I do a write-up here. So this is pretty nice. We're going to color this one blue because this one belongs to the blue square. Cynic not tried it yet, but requested playtest access 10 minutes ago. Oh, hope you get it, hope you get it. And then I want to hear what you think about it. You played some Escape from Tarkov, if I remember correctly, right? Local UV 0 to 1. So this right here, this is the normal UVs you usually have. We have a texture that is 7x7. We just this is normal texture coordinates. But then we have something called this right here. Played quote unquote some Tarkov. Yeah, okay, so that makes me think that it's over 1k hours. I love, like, I play a lot, but I play few games, you know. Like, I love like just grinding one game over and over and over. And here we have local, scaled, and offsetted UV. Let's call it offset UV. And this one is also between 0 and 1. So we have a lot of different spaces here. We want to take most of them into account, back and forth, back and forth. We also have we're gonna do it like this. Yo, what's up, Pattinson? I didn't know that was something people or chess players usually say, but I can imagine it is. Global UV, local scale, and offset UV. And then we have fuck it, something like that. Position world space, and this one goes between we don't even have a limit on it, so we can see here that's including all of our patches, so this is the full length of the white squares. And then finally we have position object space. They say stuff like E4, C4 takes check. I haven't played that much chess. I've played a little bit with my son, and he definitely doesn't say E4, C4 takes. But I can imagine the pros doing it. Okay. And what we have here is position world space. This one we have. We have position terrain normalized. That's pretty much our global UV. Then we have terrain patch index. So 00100111. Then we have terrain patch UV. And that's actually this one, position OS, but that's not entirely, yeah, it's It's not exactly position OS, but almost. Terrain patch UV, yeah, roughly. Meaning they can see 15 moves forward. I barely see one step forward. Pretty much the same here. But yeah, good chess players are I think it's pretty damn cool. Okay. So we want to go from... Okay, we have two problems we want to solve here. Or actually three problems. And let's see if we can put them into text. Maybe we can. First problem, identify affected terrain patches. 2, calculate local UV for each affected terrain patch. And 3, fuck it, we're actually just going to start with those. Number 3 is to do in shader. Because what we're going to do later on is... So, we identify the terrain patches, all of them, and then for each terrain patch we take the terrain patch data, and then we do a blit from the brush texture to the terrain data texture. And in the shader, we also just want to do it, we want to add a mask inside of the shader, pretty much. But we can start with these two. Those are, yeah, they're going to be CPU based. So we're going to calculate it on the CPU and just send it down to the shader, basically. I think they burn crazy calories in a tournament just because they think a lot. Oh, I would actually love to see some numbers on that. I wonder... what they peak at, like, per hour. So, the biggest problem here, and why I wanted to do a figure of this, is because we have this padding stuff here. So when we identify the affected terrain patches, we need to take that into account. I wonder if... like, can we do it in a smart way, or are we gonna have to do it in a verbose way? 6k calories on tournament day that's insane. That's almost Michael Phelps levels. And just by thinking, get the fuck out. Huh. People that does a lot of cardio just to get rid of burn calories should also play chess at the same time. That would be amazing. Fucking min-maxing calorie burns. Chess boxing. Um, get the fuck out. Chess boxing or chess. Come on. I guess. It's a hybrid sport that combines two traditional disciplines, chess and boxing. Two combatants play alternating rounds of blitz chess and boxing until one wins by checkmate or knockout. 1970s. Okay. Ah. Okay, I'm gonna have to check this out on YouTube after the stream. Oh well. uh, I don't know why. Maybe I should have read more on the Wikipedia, but like, why was it invented? To show that players can also be tough, or to show that boxers can also be smart? I have no idea. Or just for fun. That's definitely true. My biggest problem here is mm, okay, we could probably do it like this. This is one approach. We calculate a global UV, which we already have, and then each terrain patch has its local UV as well. Not this one, or each terrain patch has its bounds expressed in global UVs. So the blue one would have, let's see, calculator. The blue one would have from 0 to 1, 2, 3, 4, 5, 6, 7. 7 divided by 11. So the blue one goes from 0 to 0.63 repeating on the global UVs. And but then we're gonna have to loop through. That's not really what I want to do. If we could map global UVs to terrain patch indices in some nice way. Do you burn lots of calories as well? I just try to convey the illusion that I'm thinking a lot. I just want to appear smart, you know? it's hard to make a mapping. So basically what I'm trying to do is I'm trying to map one value to many. So one value should correspond to, or could correspond to, one or two terrain patches. So this value right here, if we have this one as global UV, it corresponds to two ones because we have two overlapping textures here. But in that case, now I think we can do something smart with floor and seal. So if we figure out okay, we express each texture in the size by global UV. So in this case it would be number of terrain patches times 7, but then we have overlap. Or if we assume this, we have 2 times 2 patches here. So we say that each patch corresponds to half global UVs, right? So 0.5. So if we have a point here, we're located at roughly 0.5. And then if we do... we can't do it like that. Assuming, I wonder if there's a difference between non-programmers and programmers regarding calories burned per day. Yeah, it would be extremely interesting to have statistics on all of that. And also I get, like, I wonder if it's like the better you get at something, the more you automate it in your head, the less calories you're gonna burn, right? So like first day on the job as a salary expert or HR person, you might be burning a lot of calories just thinking, learning the systems. But 1 year in, you're barely burning any calories on work because it's pretty much all automatic to you. Okay, so what I think we want to do here is we want to get the total amount of pixels we have. So we need to take the overlap into account. So here we have 11 in size. That's 3. So then we have 7 divided by 11. It is 11, right? 5, 6, 7, 8, 9, 10, 11. Yes. 7 divided by 11. So if we take this coordinate, which is 1, 2, 3, 4, 5, 6, 7. So that's actually 7. Or it's actually this one. But yeah, then if we divide this one with this one, zero 0.5. 1, 2, 3. I wonder if we can do this then. We know that the padding is 3 pixels. Right, so we do 1 divided by 7. That's our full texture. We get this coordinate here, which is... But let me draw this. Yeah, pattern recognition, developed intuition start working at some point. Also, smarter people have less activity on their brains during the day. There are tomographic ways to find if you're autistic or not. If your brain is too active when not much is happening, that's a strong sign you might be autistic. I haven't heard that one, but... I want to do these tests. I want to do tests like this on me. Like, I want to see... measure brain activity during a day or something like that. Would be extremely fun to have. One, two, three. 1, 2, 3. Yeah, we can probably do it like this. That depends on which tests, that's true. Fuck global UV. Yeah. Okay, I think we can pretty easily get the affected terrain patches. Oh, come on. So if we have position in world space, 0.5 right here. Do we care about the overlap? 0.5. 0.5. Zero point zero 0.09. Oh, that's a bad number. We've been looking at squares for some time now. Yeah, I reckon we will be looking at squares for some time more as well. Mr. Streamer. It's a bit weird. It's 100% true. So it's a correct term, I guess. Come on. I think like I'm always going back to like if we can calculate, we have 7 divided by 11, and then we check the global UV, but it's actually, yeah, position in world space 0.5, and then we have 0 here. Or 1 sec. Seeing I recently switched to Linux, my life feels complete now. Yeah, I'm thinking about doing the same. I don't know how it is to game on Linux these days, though. This calculation we do here, terrain patch UV. Actually, let's take a look at. Let's replay. Yeah, what's up, MedSD? Hey, can you explain this? Maybe we can soon. I'm trying to make sense of it myself as well. I'm worried about. So this one right here is right in the middle of two terrain patches. We can see here that it flips beautifully. 1, 3. Isn't it? I just want to do. So in this case, if this one is one of our endpoints for our bounding boxes, this one right here, I want it to take the minimum terrain patch index. So this one, this square here involves 2 terrain patches, 1 and 0. We want to take the minimum. Terrain patch indices. We do floor to int, position terrain, normalized time patch count. Inverse lerp. $24.99. Ooh, one sec. Maybe we can do. Yeah, position VS. Can we do? I guess we could probably truncate this in some way. But I wonder, would that help? 24.89. That's not it. And when we go over 24 here, nah. Also switch to NVIM, by the way. Enjoy. Okay, MetaST, if you're still here, by the way. So we're trying to... We mark an area of our terrain like this. The thing being that our terrain consists of multiple different patches located neighbor to neighbor. We pretty much want, within this area, we want to get all terrain patches that it touches, but we don't want to do it with some collision detection or anything like that. We want to do it mathematically using this information. And then we also want to calculate some UVs according to this, because basically what we're going to do is we're going to take a texture and apply it to the underlying data of this terrain. And I want to do it in a smart way. The previous solution we had worked, but it was extremely verbose. It was also CPU based, which is, we're trying to move away from that. And I implemented this highlight here in a very good way. So it can actually differentiate between the terrain patches on half a data point. That's pretty cool. But what we want to do here is we want to floor it, basically. So Here we have terrain patch 1, 2. Here we have terrain patch 1, 3. But if that square is located at the bottom left of one of our area selectors, or actually if we just if we terraform this point, we're gonna have to terraform both terrain patch 1, 2 and terrain patch 1, 3. So what I want to do is we want to get a min and max terrain patch index, and then we want to terraform both of them pretty much. So when we have a point here, so this is actually the point I'm showing. If the square is located here, we print the information of this one. If the cursor, I mean, is located here, we print the information of this one. It's just that and I want it like that, I think it's good, but when we mark this box with the terraform marker and we want to get a minimum and maximum terrain patch, then we want to get this and this one. So we want to match one to many, which sucks. But we should be able to do, it should be, and for colors that you use to identify what? No idea what that means, but you mean the different colors here. It's 4 different terrain patches. Pink, orange, green, and blue. And then the white, that's the textures, and the white is the actual geometry I try to visualize. It's weird, we have some overlap here, so if we alter this point, we actually want to alter the blue texture as well, because we have a 3 pixel overlap here. Actually, zero to one. Alcynic, it's fine. I love it. I love it. I'm 100%. Like, I'm a little bit stuck here, thought-wise, so I appreciate that you keep the conversation going on. Yeah, keeping the chat alive. It's appreciated. No, it's great. Like when my content is not, when I'm stuck and and not producing any content, it's nice that you produce some content in the chat. Fuck, it's a little bit too many spaces for me to keep in the head here. I can't go these. I can't go this deep in my head. Question: is every streamer egomaniacal? Egomaniac? Ah, whatever, to some degree. I guess every person is. Isn't that a better question? Okay, you know what? I think we're gonna. I think we're gonna. Let's see if we can print actual pixel position for the full one, for the terrain. So we run around here and we see. Do we have that one actually? No, we have terrain patch index. I want a global index here as well. I think we can work with global index. Global index, let's start down here. 0, 1, 2. Okay, so in X, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we calculate those global indices. We calculate how big the full one is as well in pixels. Like our new system behind the scenes, it supports, so our terrain can have, let's say for instance, height data and water data, and these two data textures, they don't need to be the same size, which I love. So we're gonna have to, whatever data we're terraforming, we're gonna have to fetch how big it is from that one. We can probably do it. Let's see. Do I want to print it here as well? Maybe we should just go crazy in the amount of information we print. So what more do we have? Terrain patch index. I want to calculate, what do we have here? Position terrain normalized terrain patch index. Then we get the terrain patch UV, and then we get some terrain data information. Did I draw a forbidden sign? Yeah, Hadouken speaks the truth. Okay, let's see here. Okay, so to get the global position, we have this UV. Or global index is what I want. We have this UV. We have this one as well. That's not entirely true. We have position world space, position OS, and both of these normalized between 0 and 1. That's what we have. Yeah, we don't actually have this one. Not yet. But we can get it if we do... we have this one normalized, so if we add 2 more pixels, so we scale it by... $14.11. Okay, we can do this. Terrain data information. What I want to do here is type, and then we have the value, and then we do terrain data information plus equals to resolution probably gonna add all of this into separate methods eventually. Type resolution, is that a float? Oh, vector 2 int. Maybe that's okay. Type.resolution times new vector 2 int terrain patch s dot. Can we do it like this? Get length 1 terrain patches dot get length 2. But let's see here, what do we get then? 2, so resolution times 2. We're gonna have to calculate this. It's gonna vector 2 int global solution is equal to let's do it like this, and we're going to do resolution.x times this one minus, and then we have an overlap of 3 pixels per times minus 3 times terrain patch minus 1. Is that the calculation we're looking at? Let's do something like that. Was there actually a time where you could do that on Steam? So inspect element on Steam and then edit stuff and then proceed to checkout. That's insane. Okay, size local is correct at least. 515. Fucking hell, this one is a long one now. We probably want to put it on screen in a better way, but whatever. 131, we have 4 times 4. (131 times 4, 524. Then we have 3 overlap. And we remove 3 times. Minus 3, minus 3, minus 3, 515. Yeah, your piece is sent the final price. Great stuff. Damn. Holy shit. I wonder how much money they lost. Like that. People didn't think about security back then, or at least not at the level we do now. Yeah, I was young during the 90s, extremely young. And with the limited knowledge I had, I remember doing some weird stuff, so I can only imagine. Okay, I think this is the global size we have, so that's good. 515. In what way will this help us? Okay, we can get global. I'm getting back to 7 divided by 11. That's the size for each of these. And then if we have, or so in this case we have 131 divided by 515, right? 0.2543. So if we calculate this value per point, or for the point in question, and then we divide with this one, and then we floor to int, I wonder if that will be, maybe. I want to try it. We don't need to, we don't print this shit, but global resolution, and we do global resolution. Size percentage is equal to type resolution divided by global resolution. We have an int here, that is true. Let's continue. Resolution percentage, and then we go int actually I'm just gonna do this. I just want this once. If we make it work for type, if we make it work for height, it's gonna work for all of the other stuff as well. I hope. Global resolution, resolution percentage, and then we do int. I want to try this. Terrain patch min. And then we're gonna do some calculations here, but first we need to get global index as well. That's true. But we have global UV, or we have position world space normalized between 0 and 1, and we know that we had 1 pixel here and 1 pixel here. So we want to scale it and offset it, right? $515 is our total. So we want to offset it by 1.5. Is that true? Thank you for the gift, Cynic. Appreciate it. Appreciate it. And a second gift as well. Appreciate it. Yeah, that's nice. That's nice. Fuck, if I were doing something simpler where I didn't need to think this hard, I might have joined in the conversation as well. But I appreciate it. Thank you. Yo, what's up, Mercenary Mage? Hope you had a wonderful stream. And thank you for the raid. Appreciate it. And to all the new viewers, I just want to say welcome to Math Hell. Thank you. Appreciate it, man. Yeah, those emotes, they deserve respect. They are from one of my first games I released. Okay, so my idea here in this mathematical problem is that if we have the global resolution We have resolution percentage per terrain patch. Then we can hopefully, yeah, if we get the, one sec, do I care about 0.5? I want to get the full global UV as well. No, okay, it should be as easy as this. We've done this multiple times. 1.5 divided by 515, that's the offset we have. And then we scale it first, actually, by, what is it? Ah, 515. We scale it by 515 divided by 513, I think. Oh, I hope this is... let's try it and see what we get. So basically, we have position in world space. We normalize position in world space according to the boundary of the full terrain. So we get a position in world space, but described in like 0 to 1 for each axis. And then we add the padding, and also, or we scale it. In fact, do we need to scale it by half a pixel here as well? Yeah, that's true. We probably need to scale it by 515 divided by 512. So we're gonna do it like this. Well, let's add one of these so I don't forget where we were. Let's see. Vector 2 scale. And the scale should be global resolution dot x minus 3 divided by global resolution dot x. Is this correct? But the other way around, right? Yeah, let's try this and see what we get. That's our scale, and then our offset is 1.5 divided by global resolution dot x. So then we have vector 2 global UV is equal to position terrain normalized. We can't swizzle here, so let's do terrain. What did I say? Global position terrain normalized dot x times scale dot x plus offset dot x. Something like that. Cynic, I'm gonna head out and sleep for an hour. Enjoy, and thank you once again for the gifted subs. Appreciate it. Appreciate it. Okay. And now when we have the global UV, we can hopefully use it here. By doing, so terrain patch min index will be equal to mathf floor to int global UV dot x divided by resolution percentage dot x, and then I also want a max here. Come on. But here we do seal to int. Seal to int here as well. Yo, what's up, Spires? Hope you had a wonderful stream. Happy Monday, happy Monday. Thank you, appreciate it. And this one we want to spell correct. Okay, let's take a look at this one now. I just want to print this real quick as well. Not terrain data information. Let's add it here. Yeah, let's just call it min index. Oops. Okay, something like this. Let's see how this looks, or what kind of numbers we see from this. Min index 1, 2, max index 2, 3. Am I a little bit too... Yeah, that feels a little bit too aggressive with the rounding. Let's see. One, two, one, two, two, three. 1, 2, 2, 3. Okay, absolutely, yeah. But I mean, we could probably have... Okay, this gives the correct values, but I mean, if we have this marker right here, we don't need access to... In this case, we probably just want to terraform terrain patch 1, 2. We don't really care about terrain patch 2, 3. Or in this case, it would be terraform terrain patch 1, 2, 2, 2, 1, 2, 1, 3, 2, 2, and 2, 3. That's a little bit overkill, right? A better option would probably be to... If we have the global UV, we subtract the padding, so we know we have a padding of 3, so 1, 2, 3. Then we have this one. If we're here, 1, 2, 3. If we're here, 1, 2, 3. 1, 2, 3. Okay, so if we're terraforming this point, or this is our smallest point, then we don't care about this. So 1, 2, 3, we're still within this one. That's true. Can we do it in a better way? Or actually, I'm wondering again, maybe, just maybe, if we have the local UV or position in object space, so this one, and then we jump, okay, or this one, jump 1, one. Yeah, what the fuck? We just care about one jump. If we start with this one, and then we do min. Or we could just check. Yeah, that's a much easier way to do it, I think. If we take this one, position object space normalized, it's between 0 and 1. We just calculate how big is each pixel, basically. So then we need to take the size and scale into account. Okay, so we scale it and offset it. And then we do... Now we could be located here as well, so we want to go 3 pixels. 1, 2, 3, no. But here, 1, 2, 3, yes. So then I wonder, and we just check against the local. I wonder if I want to check against the local scale and offset or local UV. Local and scaled, I'm pretty sure. But let's see here. If we do local and local scaled and offsetted, and we start here or here, 1, 2, 3. Then we're at minus. One, 2, 3. Here we're not. 1, 2, 3. Okay. Let's try this then. Experimental. So we take our terrain patch UV. Uh, Then we have a terrain patch UV scale offset, and then we want to do floor to int. Nah, it's not. We don't want to do floor to int or anything like that. We just need to check if it's less than 0. So we want to calculate its sign, I suppose. Gerald Love, what's up? Unity, question mark. Yes. Yeah, I guess we can do it like this, but I'm just questioning how nice is it? Maybe it doesn't matter. Okay. Now, maybe we just want to take this point, offset it, and then we do terrain patch UV like this. Could we do it? Yes, maybe. Okay. That would work as well. Hero Love, I just started with C#, so I don't even understand what I'm looking at. I barely understand this. Okay, so we're gonna skip this one, wait with that one. Let's do... So we need to calculate global resolution. I still want this one, okay? I think it's this one. Global resolution. Garrett Love, can you give me a little pitch for your game idea? Not right now, unfortunately, but I have a video on my YouTube where I summarize it pretty well. Global resolution. But. All of these different scales and offsets really screws things up here. Wonder, we might not need global resolution. It's probably enough with What do we have? Terrain ground shader. I want to get terrain-based data size, grid width. Okay, and the UV we do here is scale. Okay. Transform point to normalized space. Okay, we should be able to do this, but I think we should be able to do. So pretty much, I want to calculate 1 pixel step in the underlying data texture. How much is that in world space? But we have a few different scales and offsets to take into account, but I'm wondering if it's just step is equal to, we need a new vector. I wonder if we can just do rain data dot height resolution -3. Okay, I can't even write. There we go. But not really. I just need to check one thing. Okay, it's 1. But we want to divide this with dimension terrain bounds. Patch dimension. Yeah, so pretty much this one. Let's call this one resolution, and then we do vector 2. What we do now is that we ignore the padding, and we just take how many visual data points do we actually, or how many data points do we actually visualize or exists in the game world, excluding padding and stuff like that. So for texture that is 7 times 7, we actually only use 1, 2, 3, 4, 5. It's 1, 2, 3, and then half and a half. That's why we go -3 here. So then we do vector 2 step is equal to patch dimension divided by resolution. Okay, now we have the step. One, two, three. 1, 2, 3. So what I want to do now is, yeah, let's try it. I don't want to do floor to int, or do I? Nah, we're gonna do three times step in the x direction, 0 in the y, and 3 times step in the z direction. Or it's actually going to be y, but we do it in the z direction. So we just offset this point by going 3 steps to the left and 3 steps downwards. And min, and then we take this one here and this one here. And then we call this one. Okay, so we do this, and then we do this. And here we do plus instead. So we calculate min terrain patch and max terrain patch, and then we can hopefully just loop through these eventually. Let's see how it looks. 1, 2, 1, 2. That's beautiful. Let's see how it looks on the edge. 1, 2, 1, 2. Oh, here we actually have 1, 3. That's good. 1, 3. 1, 3. We might be a bit too early with it though. So this one is the one that flips it. And we still care about halves here. That might not be the best, but maybe. Huh. Okay, this might actually work. But although I wonder, do we really need to step this much? So it's this one we highlight currently. If we go 1, and then we shouldn't have it anymore, right? So 1, 2. So this one should have it. So max index in this case. And here we should lose it. Instead we lose it on the next one. Is 3 steps too much? If we're here 1, 2, 3. 1, 2. 1, 2. Half pixel annoys me, but maybe. What the fuck? Yeah, maybe we don't need to jump 3. We can just jump half and 1. 1.5. Is that enough? 1. Yeah, it's these ones we care about this time around. Oh, that's true. Fuck yeah, that's true. So if we're here, we jump a half and then 1 or 2. Maybe we just need to do 1.5. Yeah, this might actually be it, I think. Mm. Let's try this. Show info. I would like to show this. Oh. Okay, I think we can work with this. Let's try the next thing then. So I want to do. Okay, let's see here. Terraform. We have a brush here. Terraform brush. We have a texture which we want to blit. Okay. And terrain data container. Yeah. Apply clear. Yeah, so here we would just like to take a texture and apply it. Although... Yeah, we can probably do it like this time around. I wonder, the hardest part is going to be, I don't know if we're ever gonna have this case, but if we have a terrain compute buffer, if we have a compute buffer which we want to apply to a compute buffer, like I'm wondering if we want to do, or could we do something nice here? We can worry about that later, but I was wondering if we could do terrain data container apply to terrain data container, and then we fix it underneath. So we can go render texture to texture 2D, or render texture to compute buffer, etc, etc. But the easiest part right now would probably be to just do blit. We can probably add a blit method here, but we're gonna have to add like what I'm getting at is generate values. We're probably gonna have something like this. Public abstract void. Yeah, void. Lit. We do texture 2D. It's weird. Brush. Do we need texture 2D? Do we ever need this on the CPU? I don't think we do. We could probably go with render texture here, I reckon, but maybe. But anyway, we're gonna have to blit texture 2D source. And but girl love quality videos, man. Thank you, appreciate it. Yeah, the cell shading is probably the one I'm proudest of. The intro to the cell shading one. But yeah, appreciate it. Hopefully you have a little bit of a I have devlog 0 where I think I roughly explain the game idea and my biggest inspirations, right? If you saw that one. But in short, Ciao Garden, Viva Piñata. Love them. My favorite aspect of games like this is breeding. Yeah, I've thought a lot about breeding. So a big part of the game related to the creatures are still in the like planning stage. I haven't really done that much around it. But like in my design document, the part about breeding is something I'm actually thinking a lot about. I like the idea that that creatures come in all variety of sizes and colors and stuff like that. And if you want a specific color of your creature, you're gonna have to breed your way through it, or just hope for RNG, right? I think it's probably gonna be a pretty big aspect of it, but we'll see. I turned Subnautica into this, just collecting the eggs and breeding sea creatures. That sounds like a good time. Okay, so we want to do a blit here, although I wonder where we want to do it. We want a command buffer. I don't know if I want to do it in here, actually. But... okay, so somewhere, we're actually going to have to write something like... we do have a terrain command buffer here, I think. Terrain command buffer, beautiful. Somewhere we're going to have something like this. Source brush dot texture, and here we do destination. I don't know what that is. Something. And here we do some material. Okay. This code right here, we need to have it somewhere. I'm not entirely sure where we want to keep it or have it. Because then again, using this method for different types of terraformation types, like height, water, grass would be amazing. Grass and height, extremely similar. But the water, I don't know. Nah, I think we're actually gonna do it like this. I wonder. Terrain data container. Yeah, we're probably gonna have to have something like this. Public abstract void modify or alter but then we have the brush material here. Do I want this one to know about brush? Geralt Love, what's the purpose of the terraforming? Yeah, so it's basically this. A lot of the focus is going to be on the garden itself. So depending on how you terraform it and what you grow and stuff like that, different creatures are going to come and want to live in your garden. So do you have a big lake? Then some water creatures might want to move in. And stuff like that. Yeah, it sounds awesome. We just need to properly implement it. But yeah, I think it's a great idea. I mean, one of my favorite games is Viva Pinata, and they had a little bit of this, a little bit of terraforming. I want more. You attract them, yeah. So you don't go out into the world and catch them. Instead, you attract them to... so they want to come to your garden and move in. So you don't have to force them, But you will probably be able to force them, but we will see. Yeah, instead of stealing, right? But we will see. We will see what happens. Yeah, I have been thinking about having both, but like in version 1.0, we're only gonna have the attraction part. And depending on how that goes, we might extend the gameplay so you can actually travel outside your garden and then maybe steal or catch creatures, yeah? Um, some creatures might not stay unless you tame them. Yeah, so like when you go out and you catch them or steal them, you get back to your garden, you release them, and then they are very unhappy. So you gotta make them happy and make them want to stay, right? Yeah, that's a good. Mind 78, goddag, goddag. Like, I'm not entirely sure of how I want my terraform brush to communicate. So terrain base, we have terraform, we send in the brush, but how do I actually want the pipeline to look from here on? We want to do some sort of blit. I don't like the idea of sending this one onwards as well. So this command buffer we have in terrain base, I like having it here and only here. But if we have it here, then we're gonna have to, I don't remember how I did it here. Draw, render, generate MIPS. Activity texture. Get activity render texture. What can we blit between here? Blit, 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 blit. Render target identifier. Texture, render target, texture, render target, identifier, render target, identifier. I want to double check one thing here. We can create it from a texture. What I'm wondering is Unity compute buffer to render target identifier. Is this possible? That would be weird. Yeah, so this is what I want to abstract away. I'm going to go through exactly what I want to do. Gerald, can I ask what you're writing this in and how you're keeping it organized like that? So I'm developing this with Unity. That's the game engine, right? So most of it is, so game logic and stuff like that is in C#. I wouldn't say that I try to keep it organized, but sometimes, you know. If you can be a little bit more specific with the question, I would love to answer it more in detail. Okay, so what we're looking at here is we have terrain. This terrain is represented by a lot of data containers behind the scenes. Our data containers can be, so it's terrain data container, but a terrain data container can be a data buffer or a compute buffer, right? But it can also be a texture 2D, and it can even be a render texture. And now we want to apply a texture to a terrain data container. Going texture to render texture and texture to texture is easy. Very easy. Going render texture or texture to compute buffer, however, we're going to need something a bit more specific. And that's why I'm thinking that the best option is probably to send down the command buffer and the material in question to the data container. And then, so for textures, we will probably just do a blit. For the data buffer, compute buffer, I mean, we will probably do, where do we have it? Don't we have it here somewhere? Or have I dreamt this? Blit, clear, convert texture. Ooh. I just need to double check this one. Okay. Copy buffer. Dispatch, something dispatch. Dispatch compute. Really? Okay, there we go. Yeah. So we're probably gonna have to send down the command buffer and then the containers themselves will handle this shit. Although I wonder... And then we need a compute... Yeah, it's gonna be weird. I don't think we can abstract this nearly enough. We could... I'm thinking that we're gonna have like 20 different methods here. One that takes a render texture, one that takes a command buffer, render texture or texture, and a material. Maybe that's enough. Or we could terraform brush. Maybe we can do something nice here eventually. But for now, I'm wondering if the best option is to just do terrain data container, and then we do alter, modify is a better word. Modify command buffer. What the hell? We could make it so that this one returns a... Ooh, that would be pretty cool. So if we could repackage this one depending on what we want. So we could have Terraform brush here, and then this modify function or method will fetch whatever it needs or repackage it. So if we're modifying a compute buffer, it will fetch the compute shader from the Terraform brush. If we're modifying a texture, it will fetch a material, and so on and so on. Girl love, this is impressive as fuck. I appreciate it. Sometimes we're doing some real cool shit here. sometimes we're just stuck on some very simple problem, but that's how it is. So I'm thinking of keeping it like this for now. Modify command buffer Terraform brush. This one, I don't know, this one. I will see. This is something we're gonna, so when it gets to, or when it comes to terraforming height, foliage, then it's pretty straightforward texture to texture. But when we get to water, it's gonna be texture to compute buffer, I think, compute shader. Peanut Man, what's up? What's up? Thank you for the follow as well. Appreciate it. How does the terrain terraforming play into creature collecting or collection? I have a nice little video on my YouTube that describes it a little bit more in depth, but in short, I should probably add a chatbot command for this, but the player will control a character, and the character will own a plot of land, so a garden that will be, I don't know, 100 times 100 meters, and it's up to the player to terraform and grow this garden into something beautiful, and depending on what the player does to this garden, what crops or trees he or she grows, or how much of it is water or hills, depending on all of those parameters, different creatures wants to come and visit that garden and maybe eventually settle in and move there, you know? So the whole game, the initial, so version 1.0 is just inside of this garden. So for instance, if you have a lot of hills, then maybe more bird-like creatures wants to come and live in, or something like that. I don't know. The details aren't hashed out yet, but like the creatures will have different preferences, and you can terraform your garden to either be those preferences or something else. The concept is very novel as far as I'm aware, the attraction aspects. Yeah, I haven't played Slime Rancher, but I have always imagined it being something similar. But then again, there exists a game from Rare, which released in 2006, I think, called Viva Pinata, which has this attraction aspect in it. But I want to take that concept and like improve and extend it, you know. Maybe you could force them to stay. Yeah, we're probably gonna allow for something like that. But then it will be even harder to keep them happy, you know. If you, I don't know, put them in a cage or drop them into a hole in the ground which you have dug. Yeah. Egger Love, I saw that in your video, but I've never played that one. I don't know how it has aged, but it was exactly my type of game when it came out, so I played the hell out of it. Okay, for now we're going to do modify. We're going to send in the command buffer and the Terraform brush. For data buffer here, where did I put it? Before apply. This one right here is future me work. but we're going to implement this one and maybe this one. We'll see. This one first and foremost. So what we do here then is command buffer dot blit brush dot texture. Destination is going to be our texture inside here, and the material in question is going to be brush dot material. So this is everything we do here, although when we do a command buffer blit like this, we change the data on the GPU side, but we don't do it on the CPU side of things. So we're probably going to have to set some flag or something like that here, but that's also future me problem. Okay, so then in terrain base, when we do terraform here, we're going to do one, identify terrain patches. This one I think we have this one here. Identify terrain patches. 2, for each terrain patch, set up properties in material, and then call modify on the data. I don't know. And finally, when we're done with all of this, we need to do execute command buffer. So pretty much we're going to do something very similar to this. So we have our command buffer, we set up a lot of properties, and then we add a blit command, and then when we have added all the blit commands and so on, we're going to do execute command buffer. Okay, so let's see what we can do about these. Peanut Man, this could become like an ecosystem management game if the different creatures for hierarchies of form hierarchies and have rain world type AI. Yeah, I don't know. So that's still in the planning. Like, I've always imagined this with quite some smart AIs for the creatures, or detailed ones, and that's why we have a whole interaction and action system in place already, and this one is written in such a way that I can use it for the playable character as well as the creatures. So when we get to implementing the creatures, we're probably going to see some really cool stuff. I don't know how deep we will go though, but I've always imagined it like a simple version of a ecosystem type of thing, you know. But we will see. Gerald Love, I check in a lot of random dev streams, and I gotta say you're in a separate category from most. I appreciate that. I appreciate it. Maybe you're just catching me on a good day. I don't know. Okay, identify terrain patches. This one, I'm still not entirely sure that this will work, but we will see. We'll see. Yes. So the first thing we need to do to identify all the terrain patches here, right, is to get terrain patch max index and terrain patch min index. Let me show real quick here once again. But do we have some errors? Yeah, we need to... Okay, that's good. Yeah, what's up, Push Toy? What kind of categories are we talking about? So for instance, we would like to terraform this area right here, and our full terrain is multiple different terrain patches. So if this area spans multiple different terrain patches, so in this case, then we need to do, so in this case we would need to do, so this is worst case scenario, I think. We need to do a blit for this one, a blit for this one, and yeah, a blit for this one, and a blit for maybe just these two actually. But yeah, we need to identify these two, and that's what most of the morning was about. So hopefully we successfully identified those. So what we need to do here is we're gonna do, we need to calculate step. So we need to calculate these, and then we do this and this. Okay, so I'm just gonna take this and put it here. Patch dimension. I wonder if we can simplify this. Yeah, so blit is a beautiful thing. I never remember what it stands for, but I think it's like bit copy or something like that. Bit blit. Bit block transfer. I don't know. It's pretty much this. We copy pixel data from one texture to another texture, but then you can also, instead of just doing a simple copy, you can also alter each pixel. So you can apply a material or a shader and do stuff for each pixel in the destination texture. It's very handy, very nice. I use it a lot for post-processing effects or yeah, full screen effects, pretty much. But okay, patch dimension. I wonder if we can do... Hey! What the fuck? Dimension patch count. Beautiful. We already have it right. Patch dimension. Dimension patch count. Okay. I don't remember us setting it here, but that's beautiful. I wonder if we use it... Yes, we use it for terrain projection matrix. Okay, beautiful. So patch dimension we already have. Oops. Yeah, so this one we remove. Not here. Terrain data type, height, resolution. I'm actually gonna do this. Let's see here. I think we're gonna do terrain data type. We're gonna have one that is resolution, and then we're gonna have one that is resolution with padding, I think. Girl Love, do you have any teammates? Not at the moment. Which might explain the speed we're moving at here. I wonder how I want to redo this, though. We're probably gonna do... I think we use this one, or we call this one quite a lot. Yes. So let's clean this up. We call it a lot here as well. I think we're gonna do it like this. Base resolution. Public static vector2 int. Resolution padding. And then we're gonna have public static vector2 int full resolution. Here we don't need to do switch. Instead we can just do return base resolution. But what is it? Type dot base resolution plus resolution padding. But here we also want type dot. I think this is a much cleaner way to do it. So base resolution 128. We're gonna clean this up eventually as well. Base resolution, so this is... How could I... summarize this one in a nice way. Yeah, it's our underlying data, the data points that actually matters. And then we have padding and a centering offset. Okay. UV scale, then we want full resolution, full resolution, full resolution, full resolution. Terrain base. Yeah, here we do -3. So resolution, instead we can just do base resolution. Do we use this often? No, we just use it once. Oh no. Oh yeah, this is just temporary as well, so I don't really need to write this one, I reckon. Ah, that's true. One sec though. Resolution vector 2. Okay. We don't need to cast it ourselves. We use it one more time here. Get full terrain grid size. Oh, here we do the same thing. So nice. Here we can just do type base resolution. And then we're back down to here. Resolution, patch dimension. Okay. What IDE are you using? So we're talking about this one, that's just VS Code. It works for me. It's pretty lightweight, customizable. So I'm happy with it. Okay, this one. We're gonna calculate offset here instead, I think. Step, so we're gonna do... Let's do it like this, actually. Vector 3 offset equal to... Oops. What I want to do here is... But 1.5, this is the padding, so we can do this here. And we don't want to do height here, actually. We want to do brush dot type. And here we do brush. Let's do it like this. Brush dot type dot padding. Resolution padding dot x times but we want to take 0.5 f times this one. So it's this one. Times step x, which was... I'm gonna add parentheses here, even though I don't think we need them. But I like them. And here we take patch dimension.x divided by resolution.x. And then we do the same thing with, or y is actually just going to be 0.0. But this one, resolution y, patch dimension z, resolution padding y. So then we have offset here, we don't need step. And here we do point. We're going to fix that one as well, but here we do offset. And point is going to be brush dot brush position, I reckon. And then we do the same here, but we add it. So it's basically like this. Actually, we're gonna do some additional stuff here. One sec. But it's basically, we have this terrain and then we draw a... We have a marker on this terrain, we put it here maybe, and then we draw it. And we want to calculate this smallest point and the maximum point of this marker, and then we want to check the minimum terrain patch index and the maximum terrain patch index. Oops. Gary Love, sorry if I'm distracting you. Don't sweat. Like, I enjoy questions and input and whatever, so just ask away. It's appreciated. Is there a reason you use VS Code over Visual Studio? I actually I don't have that much experience with Visual Studio. When I started developing in Unity, I went with Visual Studio first. And I mean, it was good. It was okay. It worked. It did what it was supposed to, but it was quite... My experience with it was that it was kind of slow, you know, very heavy. So, and I've always enjoyed very lightweight IDEs. So when I reinstalled my computer, I think it was, and it was time to download a IDE again, I searched a little bit because what better time to switch IDE when you're gonna install a new one, right? And then I just saw that a lot of people recommended VS Code. Compared it to Atom, and I enjoyed Atom very much. Harukanan VS Code is not very lightweight these days. Maybe that's right, but like it's still, I think it's still more lightweight than my experience with Visual Studio, but you're probably right. So Atom, let's see if I can open it up. I don't know if I have some old files open on it or something like that, but let's just double check it. So this one, when I do web dev stuff and stuff like that, I usually use Atom. It's extremely lightweight, I would say. But yeah, for this game dev stuff, I need some more features and stuff like that. So this is VS Code, if we're talking about this one. Okay, so we want to do one more thing here, first of all. Oh, you mean this one? This is just draw IO. It's just a website where you can draw very nice figures and stuff like that. It helps me quite a lot when I want to think and solve geometrical issues. Harukanan, too bad GitHub had Atom killed off. Oh, that drama I haven't heard. But it sounds very unfortunate. But I don't know the lore. Let's see here. Atom was developed by GitHub, wasn't it? But then GitHub was bought by Microsoft. And Microsoft killed it. Or anything built with Electron needs to be put down. That's... I don't have any strong opinion there, but I'm gonna take your word for it. Okay, so it's actually not brush position we want to alter. It's actually if we jump to Terraform brush, it's actually position brush radius. It's actually brush position and brush radius together, I think. But yeah, some of these things are leftovers, right? Harukanon, what is that VS extension you have to get a browser on the right? It's actually Microsoft Edge tools. So it's actually meant for when you do web development and you need to run it and test it real quick. But I use it to browse other websites as well. Initially, I just want I just want a GitHub viewer inside of VS Code, but like GitHub pull requests and GitHub issues was the only available ones, and they're pretty nice. I think you can do something like, I've shown it before, but you can do this, so you can reference issues in comments like this, and that's pretty damn nice actually. But then if you want more information, you're gonna have to open it in a external web browser, and I don't want to do that. If I had the time, I would love to develop a like a better or more detailed GitHub integration in VS Code, but time. I'm on Debian 12, so I could get Edge by selling my soul or whatever. It doesn't even Yeah, I guess it runs on Debian. Gary Love, if you pull this off at the level of quality you show in your video, it's gonna be a fucking slam dunk game, man. Yeah, I hope so. I hope so. We will see far into the future. But hopefully I will be able to produce some cool videos / tutorials soon enough. Okay, so we want to show the brush marker is actually a square, right? It's brush position minus brush radius to brush position plus brush radius. So I want to add, I think we're gonna add something like public bounds. I don't really like this naming, so we're probably gonna change this soon as well. There's really no reason. It's a little bit verbose. Because we basically get it by taking Terraform brush dot brush bounds. It would be much nicer if we just do Terraform brush dot bounds, right? But let's keep it for now. New bounds, and here we do brush position, and then it's size. So we do 2 times radius, brush radius, times vector 3.1. Okay. So in terrain base then we have resolution offset, and I also want to get, I don't need it here. Let's do position terrain normalized min. Can we clean this up? We're gonna do this. So here we want to do brush dot bounds, brush bounds. See, this is what I'm talking about. Brush dot brush bounds dot min. That's our minimum point. And here we do brush bounds dot max, and that's our maximum bounds. And I really want to try and see if this works. So I think we're just going to print these first of all. Or actually, I will see, we'll see. Girl love, I'm nowhere near your level of coding or modeling skills, but if you ever need music work, keep me in mind. Will do, will do. Yeah, I want to see if this is correct. How can we print this in a nice way to properly check? Okay, action interaction terraform, terrain base terraform. Okay, so we do call this one. That's good. Let's print some stuff then. Let's just do debug.log fuck, I think I want to do it like this. Because eventually what we're going to do is we're going to have a for loop here, right? So we're going to do for int equals 0, I is less than or equal to, or less than. Less than or equal to. And it's not 0 here, it's terrain patch min index.x. So we start at that one and then we go to terrain patch max index.x plus plus. Still trying to learn this keyboard layout I've got going here. It's not going very well. Okay, there we go. And here, for now, we're just going to do debug.log terrain patch let's just write it like this. Terrain patch plus I plus J. Yeah, let's try this. Compiler errors. Yes. And here we do -3 as well. So base resolution.x. I thought we had all of these taken care of. Keyboard layout. I bought a new keyboard. I went from I'm still doing the Nordic layout. I'm too old to switch from that one, but I went from my previous keyboard was a extremely big one with numpad and everything, and now I'm going a little bit more minimalistic. I don't know exactly what it's called, but my new keyboard is pretty much half the size of my old one. Okay, so here, information, we're at terrain patch 1.2, so let's see what happens if we terraform this one. Then we get terraform terrain patch 1.2. Okay, beautiful. And we want to stop terraforming, and then we run. And here, terrain patch. Okay, this one I'm very interested in. So this square right here, it's shared between two terrain patches. It's shared between 1 and 2 and 1 and 3. So if we do terraform here, and we actually get here, terrain patch 1, 2, and 1, 3. So that's beautiful. And now let's see if we do something like this. Now we're going to go a little bit crazy, okay? Oh. The fuck? Okay. Does the shader start to break at this size? Yeah, we have some small issue, but... What do we have here? You're never going to be able to terraform this big of an area in-game. I don't think. Okay, so I think we have 6 different terrain patches here, roughly. So if we do terraform, what do we get? We get 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Fuck, is that 9? 9, 9, 9, 9, 9. 9. Let's see. Okay, let's see if they are correct. I'm a little bit worried about 0, 1, but maybe not. I think this one is 0, 1 actually. 0, 2, 0, 3. Ah, no, that's correct. That is correct. Because it overlaps just at the edge here. Oh, beautiful. So this is 0, 0. This one is not included. 0, 1, 0, 3, 0, 2, I mean 0, 3. We have to remember that this one is actually a square, even though it's being rendered as a circle. 0, 3 is included as well. And then we have 1, 0 not included. 1, 1 included. 1, 2 included. 1, 3 included. Then we have 2, 0 not included. 2, 1 included. 2, 2 included. 2, 3 included. And then we have 3, 0 not included. 3, 1 not included. 3, 2 not included. And 3, 3 not included. So yeah, this full terrain we see here, it actually consists of 16 terrain patches, all of these. And now we have just identified mathematically, previously we had a terraforming system in place that worked, but it used colliders and physics boxcast and stuff like that. This one is much cleaner. And now we identified the patches in question. So it's this one, this one, this one, this one, this one. Actually not this one. This one, this one, this one, this one, this one. So if we would terraform here, we would actually do 9 blitz. So we would apply this terraform brush to all of these, the data textures for these terrain patches. And that's what we're gonna do next, actually. But this is very nice that this works. I'm happy about that. Heads, Blee, what's up? What theme is that in VS Code? Do you have maybe your settings pushed online? Unfortunately, I do not. But if I remember correctly, in fact, let me just double check real quick. Where do we go? Where do I find the theme? I know that I'm pretty much going with the default settings, but then I think I changed the background color. That's pretty much it. To like now I started this. I really want to get to the bottom of it. One sec. File preferences, themes. Is it color theme? Yeah, I think my theme is dark modern, which comes with VS Code by default, I think. But then I've also downloaded the GitHub themes, and I use some of the background colors from the GitHub theme. So we can check here. This is GitHub in the web browser, and we can see here that the background on this one is the same as the background here. So that's pretty much all I've done. Yeah, if we could actually terraform this big of an area, it would be a we would need a way bigger shovel, that's for sure. But okay, one problem solved. I think we're probably gonna notice that it's solved plus minus some error margin. It usually is. So this one is done. Let's put this one on its own line. For each terrain patch, we actually have this for loop as well, so we can do like this. Okay, set up properties in terrain brush material. This one is gonna be the hardest part, I think. Maybe that this one was harder, actually. We'll see. Because what we want to do in this stage, we have done this previously in a little bit of a simpler version. But we have one texture with one UV coordinate, and we want to apply that texture to another texture that has its own UV coordinate. So it might look a little bit like this. Let's use this one, that's nice. So we have actually we can do with constraint. We have this texture. That's our terrain data texture. And then we have this texture, which is going to be our brush texture, and we want to blit this one into this one. The only problem is that sometimes this one might be located here, or here, and sometimes it might even be located like this. So when we blit this one into this one, we just want to take, first of all, for this one, we just want to alter this tiny bit here, and we want to do it with, so we, for the terrain data, we want to alter the top left area, and for the terrain brush, we want to fetch from the bottom right area. This whole project is the hardest part. Yeah, okay, that's true. That's true. But Hetzbli, sorry about the mispronunciation. Putting up the theme might be a good idea. I mean, it's nice to just be able to reference a GitHub repository instead of going into detail, you know. Garrett Love, why is everything divided into 16? Are we talking about the terrain patches or something else? The patches, we can actually decide ourselves how many patches we want. So we have our environment here, and so here we can set up like how big should the terrain be in meters, and how many patches should we have. So right now we have 4 times 4 patches, so a total of 16, but we could go with 2 here. This is not going to be customizable in game. I just have it like this because I haven't really decided on how big of a terrain or how big of a garden I eventually want. So we want to be able to do some trial and error here. Okay. So what we need to do now is we need to find some common middle ground between these two, I think. And the question is, global UVs is probably what we want to work with. We can probably describe this box in global UVs and this box in global UVs. I think that's a pretty good middle ground. Or I don't know. Or I might, yeah, we don't want to make this too complicated. We just need to describe this one in this one's UV space. Okay. What's up, Atrom? What are you attempting to solve? How can I summarize this problem? Given a box selection in world space, we're trying to execute a set of blitz into texture space. That's probably how I can summarize it. Garrett Love, would that be normalizing? It's one type of normalizing, I think. But okay, so what we want to do here, so this box here, we have a minimum point and a maximum point, right? We have it in brush bounce min and brush bounce max. We should be able to... Oh, fuck yeah, we should be able to do this, I think. Yeah, we got it. Okay, I think this is pretty easy. Pretty easy. We just need to do this twice. We need to do this twice. And here we're gonna have min terraform brush bounce min. And then we're gonna do it once again, but we have terraform brush bounce max. Because that's pretty much what we're doing here. We're transforming this from world space into terrain patch UV space. But I think we need to scale and offset it as well, actually. One sec. That's not entirely true, because once again, terrain patch bounds here, they just represent the active parts of the texture. So i.e., if we have a marker here, this is part of the padding to this terrain patch. If we have the marker here, it's going to be constrained to this one. So we need to take bounds and make it a little bit bigger if we want to rely on this. What could we do? We could offset these bounds, i.e. just make them a little bit larger so we get the full texture. So that's 1.5 pixel. Maybe that's the preferable way of doing it. I wonder if we can use... Could we mathematically use these? Resolution 1.5. Maybe we could. UV offset. Yeah, I think we could. scale, but we would have to do... We want to scale the other direction, don't we? So we would need to do 1 minus UV scale. And I see one thing we can do here is... but then we're gonna have to throw one as... we could do it like this. But I think we can use these actually. But we have to be careful. Welcome back, Cynic. Welcome back. Atrum, how come you don't use units built in terrain? That is actually a very good question. I like to reinvent stuff. But it's also, when I did the planning for the terrain system in my game, I listed all of my constraints and functionality I needed from my terrain and stuff like that. And then I compared the pros and cons with going with a custom terrain solution and Unity's terrain system. And that's why I ended up in my custom one. We're gonna have to... I want to have full control over the data, because we're going to do some weird terraforming stuff. And I also want terraformation to be available like during gameplay, optimized as hell, you know. But we'll see. Cynic thought about this one as well, never had the courage to ask. Well, now you know. I think like the Unity terrain system is amazing. But since a lot of the gameplay in this game is going to be terraforming, I needed to have my custom solution. But you know, I've been proven wrong before. I wouldn't be too surprised if eventually, when the full Terraform system is in place, and we notice that we could probably just have used the Unity terrain system and just lost 20 FPS or something like that. But we'll see. We'll see. Yeah. So like, I also like reinventing the wheel, or I already said that, but like, I like to do it because I'm a little bit of a control freak. I really want to know everything that is going on behind the scenes. Of course, I can't do it with everything, but the terrain was one of those things, you know. Geralt Love, this is what I always imagined pirate software streams were like, quite the opposite in reality. I actually watched quite a lot of pirate software back in the day when he was averaging around 400 viewers, and let's just say it was a lot more development going on back in those days. But I don't blame him. Like, developing games or development in general is very hard, and takes a lot of energy, and if you have the choice between sweating in an IDE all the time every day or just playing some game and relax, I would probably choose the latter as well. A few days at least. Cynic, damn you, OG viewer. Yeah, I am. I've been active like in the Twitch game dev scene for quite a while actually, but very fragmentic. So sometimes I just used to view like some of the other streamers. Girl Love, you're doing the opposite of an asset flip. Yeah, I guess. I guess. Cynic, I wonder how Valheim does it. Probably uses units terrain. I only have like 4 hours in Valheim, but they don't have any terraformation, do they? If they just have a static terrain, yes, then it's probably Unity terrain. Atrium, I used shaders to deal with the texturing, then I used the UVS texture lookups. So for like texturing the terrain, right? Girl Love, depends on what day you ask me. Most of the days I actually love myself, yeah. Okay, but back to this UV scale, UV offset, UV step. Cynic, but you can mine a hole in the ground, so I think they do. Okay. You can mine a hole in the ground. Can you? I'm gonna have to check that out. Valheim has terraforming shit. Unity holes, yeah. Okay, let's put it this way. Now I'm fully committed to this custom terrain solution. We're gonna have to find out at the finish line if I could have just gone with Unity terrain or not. I'm betting I couldn't, but we'll see, we'll see. Not, or I guess I could always have, but I would have had to extend it a little bit myself. But this has been a learning experience like no other. So still knowledge gained, knowledge gained. Okay, so what we have here is local, no, we have, yeah, local scaled and offset UV from 0 to 1. And we want to, yeah, we want to scale it, we want to make it bigger. So we're gonna have to do 1 divided by UV scale. And then we're gonna do, is that enough? Maybe that's enough actually. Or do we need offset as well? UV scale. Here was an early texturing test from my terrain system. Oh, let's see. Oh, so you went with is it an oct tree? It's a marching cube implementation. Yeah, okay, very nice. So an oct tree type of structure later on for. I'm just trying to use that term because I recently learned what it actually meant. Or we are using quad tree, right? But okay, but it's a marching cube, so your terrain can support overhangs and stuff like that, which Unity terrain cannot. So if that's something you want to support, then you have to go with your own custom solution, right? If I remember correctly. Like, is it enough to scale it just? No, it's not. No, it's not. Or is it? Zero, if we scale 0. Or 1. Now we need to offset as well. Okay, so I think what we're going to do here is terrain base terraform. We're gonna do something very similar to this for each terrain patch. But the terrain patch bounce min and max here is going to be scaled and offsetted, okay? So we're going to take this. We're actually going to take both of these. Garrett Love, I hear terraforming in Valheim causes FPS issues as well. Ah, maybe. Yeah, we'll see. If this terrain solution causes bad performance, I have no one else to blame but myself, at least. That's always something, isn't it? Okay, so here we take I, J. So we fetch the terrain patch in question, and then we want to calculate the UV. But I think we want to do it like this. Can we just do terrain patch dot bounds dot min? What I would love to have here is Swizzle like this. I would love to be able to do stuff like this. Or X dead in this case. That would be amazing. Cynic, that's usually how it is being a solo dev. That's true. I don't have to waste any time on doing git blames though, because I already know the answer. Atrium, I just move the mesh generation to another thread. Then when it's fully loaded, I do copy into Unity. Oh, that's nice. Okay, so what we're gonna have to do here instead is do min. Okay, let's do it like this then. Dot x times brush dot type dot uv scale dot x. But we also want to have 1.0f divided by this one. And then we do minus. Ah, ba, 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 ba. One sec, offset. We can probably go with offset. Okay, we're gonna do some experimentation here, but I think we should be able to do something like this. Why said I'm very worried about this one. Bounce min. Bounce max. Atrium, mostly because the marching cube normals and smoothing calculation is expensive as fuck. Oh yeah, I can imagine. Cynic, I hate when I see shit code and say who the fuck wrote this shit and git blame shows you. Yeah, been there. Like earlier in my career, yeah. You get humbled real quick, that's for sure. Okay, but this is not enough. These are bounce min, bounce max. But can I try this already? I don't think I can. We're gonna wait a little bit here. Now I just want to convert this into UVs. And we can hopefully do it with this. But I don't know. We'll see. We will try. We'll try. So basically what I want to do is vector 2 UV min is equal to new vector 2 inverse, yeah, we're doing mathf dot inverse lerp between bounce min dot x. Okay, is this what I want to do? Bounce max dot x. Brush bounds dot min dot x. Yeah, it's going to be really interesting to see if this actually works. Is it said? UV max. Something like this. I want to debug this one. The idea is that these 2 points, they define a square in UV space, and that's that is basically the area we want to change, but I think we're gonna need some additional information, unfortunately. Or actually, maybe not. Maybe not. We'll see. Cynic, but then you get a bit happy as well, just to see how much you have improved. That is true. That is true. Atrium, thank you for dropping by. Appreciate it, and enjoy that that lunch. I'm getting a bit hungry myself, but we're probably gonna go for another hour, I think. Yeah. Okay, let's see what this results in. I'm very intrigued. One sec. I would also need, I would actually like to debug whatever we printed previously as well. Okay. I'm gonna try something easy first. Terrain patch 1, 2. We have 0.55 to 0.82, 0.60, 0.87. I think that's pretty much fucking spot on. Maybe actually. Yeah, what's up, oi bruv? My British ain't that good. Actually, let's try. .56 to 0.58, 0.83 to 0.86. Nah. That's wrong, I think. But then again, it's still wrong. Because if we terraform with this marker, we should only get, or actually, 2. Can we get to the bottom of this at all times? There we go. We should only be seeing 58, 59, 81, 82. Maybe. .55, 57, 81, 83. Maybe. Maybe this is correct. We're gonna have to do some proper testing. Your love, it's almost 5 a.m. here. Oh, damn. Enjoy that sleep. I will check in going forward for sure. Appreciate it. Appreciate you dropping by, shooting the shit. Yeah, I will try to keep it up. Thank you once again. Ling Ling, I'm good. A great start to this week, I think. How about you? Okay, you know what? To properly test this, I think we're gonna have to change some data, actually. I mean, yeah, it's too little. It looks kind of okay. This could probably be correct. I just don't know yet, actually. So we're gonna change some data, switch to this scene, and then we can actually change the data here. We actually have there's barely any calculations going on here, so it should be fine. Okay, fuck it. Let's alter some data. Let's take a look at my old Terraform shader. Brush strength, brush operation. We're gonna go easy here. We're gonna change this one, make it a little bit more basic. Color right mask, yeah, whatever. UV boundary brush bottom left, UV boundary brush top right, UV boundary step error margin was something we used previously. I don't think we're going to use this anymore. I think we can do without it. Actually, before we dive into this shader and simplify it and then test it, I'm just going to run AFK real quick. So we're talking 2 minutes tops. I need to get something to drink, so I'll be right back really quick. Okay, back. Sorry about that. Let's see. Okay, so we're gonna be real simple here, I think. What we said, these are the two properties we want to set. So bottom left UV of the brush and top right UV of the brush. But one sec, do we need... Let's take a quick look here at Blit. Hmm. Yeah, the scaling is gonna be a mess to get right here as well, but... I think this should be enough. I wonder if we can just take this one and use this one. Brush strength, brush data. Yeah, we just need to set these two basically. For now, I'm gonna do Terraform default material. Yeah. Okay. Okay, so for now, I'm just gonna take these bottom left, top right. And we do very interested in if this works. And then finally we do terrain patch dot data brush dot type. We probably don't want to this data method. I don't want, or this property, I don't want it to be public, so we're probably going to call a method in terrain patch eventually. But for now, this is okay. And here we call modify, and then we send in terrain command buffer and our brush. And then after all of this, we do terrain command buffer dot, or actually, no. Graphics dot execute command buffer terrain command buffer. And then we want to clear that shit as well, I think. Yeah. Okay, let's try this. Assuming watching some crazy clips I did in the finals right now. Want to play it so bad. Ah, nice. That's another game I've not played, but it looks very good. Atrium, you're using URP? Yes, sir. Okay, time to test this. I think we have gone through every stage and it should look good. Assuming it's a Swedish game, yeah, it's X Dice people, right? If I remember correctly. Ooh, did something happen here? Okay, we get an error at least. That's something. If I went to dereferencing, casting from texture 2D to render texture. Oh shit. That's not good. That's not good at all. One sec. Yes. Shouldn't we be able to do this? No, are we gonna have to? Yeah, maybe. Oh, this one I don't like at all. See here. Yeah. This one I don't like at all. Don't know how to do it through shaders properly, but Texture 2D has a read pixels to read from render textures. Read pixels is on the CPU side of things, right? I think we use it somewhere, or we have used it previously, but now we wanna make this GPU of ours work. And if I remember correctly, we can't do it as texture 2D, so we're probably gonna have... Yeah, I know. Yeah, okay, so yeah, this is when you... Oh, I'm sorry about this. So this is when you read from a rendered texture to a texture, right? So it's pretty much when you want to read back from GPU to CPU. Okay, I'm sorry about that. But this is not what we're going to use right now, I don't think. But. So the problem here is probably that we can't do it to a texture. We need to have it as a rendered texture. And then we're gonna have to read it back if we want it on the CPU. But let's see here. Okay, here's the thing. Or this is my thought process. Do you need it on the CPU side even? Yeah, okay. So my thought process, I'm going to go through this right here, is we have terrain data texture container. We have one that has texture 2D, and we have one that has a render texture only. My thought process here was that some data here we're actually going to need on the CPU. I can't give any more examples right now than height, because we need it for our height collider eventually. This is just a mesh collider currently, but eventually it's going to be a height collider. So if we want objects to collide with the ground, we need the height of the ground on the CPU, right? So my idea then was that for texture data that we need on the CPU as well, we store and use it as texture 2D. Pretty straightforward. And for stuff we only need on the GPU, we just do render texture. But I wonder if the better option is to Yeah, the better option is definitely to just have one texture container, and it's purely a render texture container, right? And then we can ask this container for the data on the CPU, and then we have a flag in here. If that flag is dirty, i.e. we have updated the GPU data, then we read it back. Otherwise, we just give it back as is. Is the terrain height based on texture? Yes. So here we can probably do even more cleanup. That's pretty nice. Let's take a look. One second. Okay, so I think we're gonna do this. Terrain data texture container. You serious? Render texture format. Okay, but I want to add some more stuff here. MIP count. Don't we have... Are we gonna have to do... let's do it like this. Okay, beautiful. Yeah, now we can't do this anymore. Now we're gonna have to work with the flag, but that's okay. Texture apply, we don't have this one anymore. If I apply here. Yes, set data. I just want to test my... generate values as well. That's true. Like, the question is how we want to represent this on the CPU side of things. And I'm wondering... Oh, this one is important as well. Depth buffer. I hate that... Hate and hate. Looking through my render texture code, actually never use create. I think it does behind the scenes, but don't quote me on that one. Yeah, most of the time you're probably fine. But if you sometime notice a bug that you can't recreate, not calling create might be the culprit. Maybe. Can we actually do this? Let's see, Unity, I've never done it this way. Unity fill, render texture from CPU. Oh no. Yeah, previously when we did this, we did it from texture. That's what I'm questioning here. Blit, we can do it from a texture, but not to a texture. Okay. Because if that's the case, then I'm thinking about doing something like this. Let's see here. Render texture, texture. then we're gonna have to have both. I'm gonna have to have both texture 2D and texture here, render texture here. That's we pretty much had that previously, but that's, I think it's okay. So you're crazy watching 8-year-old YouTube videos, don't even remember these. Oh, I've been there as well. Watching your own old YouTube videos. 8 years, that's not that far. That's not that old either. Dude, time flies for me. I hate this. Ooh, 1 sec. Let's check that Atrium. You might be onto something. We're talking about... One sec. We have texture 2D graphics. What the fuck? Let me copy that link. What is texture 2D? Oh, that's not a link, it's just the coloring. Okay. Do we have graphics here? Oh, I mean... Oh, beautiful. But this is read only. We can try it. Yeah, that's true. You're fucking spot on, man. I think. Let's try it real quick. We can do it real quick by doing... This worst case scenario, we just do Control Shift. Oh, did I go too far? I don't really know exactly what this is, honestly. But can we... Oh, yeah. So this is usually... You use it to check if it's been updated and stuff like that, right? Oh no, did I screw up? Yeah, I did. Okay, I think what we're gonna have to do here is what we had way back when. Or way previously. and it's a render texture and a texture object, but it feels weird. I don't know why that would be needed, actually. Why can't you just have texture 2D? If you want the object to be... if you want the object to be accessible both on CPU and GPU, shouldn't texture 2D be enough? And then you want to be able to alter it both on the GPU and the CPU and read back and forth. Maybe not. It's because sending memory to and from GPU is very costly. Yeah, I know, but it should still be like texture 2D, right? It's represented on both the CPU and the GPU. Like you can do blit with texture 2Ds. We should have, and you have a lot of control as well. So I'm just shocked that we can't write to the GPU representation of this object with blit. But like destination is only what graphics texture, isn't that the fuck? Yeah, okay, so it's that it's read only. Am I getting that right? Where do we have it? Was I looking at the wrong graphics split? Oh, we can probably do it with graphics split instead. We don't even need to send it. Is that true? Then it's read only, or hmm? Cynic, I want to start on a project, but not sure what. Any ideas? Not necessarily game dev. I might have some ideas. Like, do you have any preferences, like web dev or something like that? Would that be okay, or like in what area? Why can't we use this one here, by the way? This one. That's weird. Oh, did I use the wrong one? Sorry. Fuck, I'm tired, man. Thank you, appreciate it. There we go. Oh, let's try this one. If this works, thank you. Cynic, anything really. I like making programs or tools. Okay. I've always wanted to do, once again, don't have the time. Like I wanna create a bot that summarizes Wikipedia articles like graphical timelines, you know. So if you enter World War II, the Wikipedia for World War II, then you have a tool that converts that into a nice, beautiful timeline graphic, you know. That's one project. Okay, we don't get an error at least. That's very good. But fail to set the active render target, ensure that it's a valid render target. So what I'm a little bit afraid of is that we can't do this because... that's weird though, but because... I have so many things open. Here we go. Because I'm wondering if, like, that this one is read only. But that's weird, isn't it? But one sec, we might need to do something here first. We might need to call this one. Or let's try it. Graphics texture here. Is read only, but that shouldn't really... That shouldn't really screw it up for us. You can also try... Oh, nice. We're gonna try that one. Let's... Fuck, maybe that's a better option. Beautiful. So... maybe, maybe not. Let's try it. Yeah, otherwise I have a solution that works, but we're gonna have to do some rewriting on this container, but that might be for the better actually. We get the same... Hmm. I wonder why this one doesn't work though. I wonder if... yeah, sad indeed. But it might have... I wonder if... I'm wondering if... Mm, okay, we're actually gonna do it like this. I'm not entirely sure I like this though, but yeah, we're probably terrain data texture containers. They are like in 90% of the cases, they are only gonna be located on the GPU, right? So we're gonna have a render texture behind the scenes, but then we're actually gonna have a texture 2D object. That's weird as hell. Basically, what I want to do is something I would think that Unity Texture 2D already had. And it's basically just having a render texture and a texture pair, where the texture 2D represent the render texture, but on the CPU. But that's basically what texture 2D should do. It's weird. Oh. Mm. Mm. Render texture identifier, I thought. Render target identifier. We can probably do this. Hmm. But this should work. Have I missed something? Okay, let's try this. Texture. Okay. I wonder if I have texture dot I wonder why this wouldn't work actually. Texture 2D, we can work with it on the CPU, but it's pretty much mostly on the GPU, and that's what we point at this point, but we get dereferencing. Casting from texture 2D to render texture. Graphics, copy texture. Yeah, the only problem with this one is that we can't. Yeah, exactly. That's unfortunate. But can we do something cool with this instead? The good thing with this one as well, what I love with this one is that you can copy like parts of the texture, right? Source X, source Y, source width, height, destination X, Y. It's fucking beautiful. But it's also texture to, or pixel to pixel. And our brush texture might actually be 32 times 32, yeah. But like the only thing we need to do here, okay, so I know one way we can do this and it will work, but doing it that way just feels extremely weird, because doing it that way is what I would anticipate texture 2D to be able to do. But let's do it like that, make it work, and then we can maybe fix it at a later point. I need to run soon as well, so it would be nice to just see if we could make this work first. Um, we do texture like this, then we do texture 2D. Texture copy, and then we do how color space conversion are applied on the texture. Is that so? Beautiful. Okay, so we do it like this, and then we do texture copy equal to we do it like this. Yeah. I hate that these two are interchangeable. That's weird to me. So we have render texture format, and then we have texture format. Would love to be able to change between them. Because we definitely want these to be the same, but can we do... I've done this. Yo, what's up, Hisoka? A little bit worried about the format here. What is happening here? I don't even know anymore. But I guess in some way we're developing a game, or trying to. Okay, I just want these formats to be the same behind the scenes. One sec. I know we did something similar to this, but I wonder how... It's been a while. It's been a while, to say the least. Let's see if I can find it. Okay, let's see. I might have it here. No, I don't. He's okay. What genre of game are you developing? I'm doing a little bit of a cozy creature collecting type of game, but it's more like creature attraction type of game. It's like Chow Garden in Sonic or Viva Pinata, if you've ever played. I want to try this real quick. So what can we do to just make this work, basically? Texture format to render. Texture format. Yeah, it is. Hizikamoro, we're using Unity. I wondered this as well. Can we use... Can we use graphics format? Graphics format. Okay. Let's use this one then. And then I wonder, can we use... we can use graphics formats for both. Okay, beautiful. So with height format, so we can't use this one, I reckon. There we go. Then we have that one, and then we want to do descriptor.srgb false. Atrium has some real nice information. Okay, now we have the render texture, and then we do a texture copy. We do graphics format here as well. So we do format. That's all we need. Hopefully this is enough. Oh, come on. With height graphics format, texture creation flags, texture format, graphics format, MIP count. Okay, we still need this one. So let's do 0 here. And interesting. Not render texture. Where do we have? Don't we have any documentation on this one, or? Hisoka, nice, but I'm more of Godot fan. I tried Unity before, but I didn't like it back then. I started using Unity when Godot, well, it was pretty small back then. So Unity is pretty much everything I know. I've used Godot for a total of 4 hours, I'm pretty sure. Don't upload on create. This one tells me that we don't upload to the GPU. And I like this. Our texture copy is supposed to be only on the CPU in this case, which is weird, I know, but okay. Now we create these. We create these with the same format. Set render target, value. We can get the value here. And we use, every time we try to get the value on the CPU, we always use texture copy here. But we need to do one thing. Modify, we can remove this one. Apply, to do implement. Cynic, need to head out. Was fun to see you live. Thank you for dropping by, and thank you for the subscriptions. I appreciate it, and hope you feel better soon. Okay, so this is pretty much what we're gonna have, and then we're gonna have a private bool dirty. So every time, let's see here, private void fetch data from GPU. Whoops. Fetch data from GPU. And then we do graphics dot blit, and we want to blit from texture. Actually, blit is not what we want to do. We want to do AEM was up, crossfaded. No idea what that means. It's okay, Godot is missing a lot compared to Unity, but I like it easier. I find more fun to use it. Yeah, that was also my 4 hours of experience, but I mean, Godot is... it's fucking growing. Like each minute, it feels like. So it will be up to date soon enough, I think. Currently active render target. We probably want to do something like this. We can do copy texture. Graphics copy texture, here we go. Source test, beautiful. Read pixels. We don't even need to set this one. Fetch data from GPU, and after we have done this, we do dirty is equals to false. And then we just do get pixel data. Like these methods right here, they are pretty much never going to be used. But if they are, we want to make sure that we have the latest data right. Generate values, here we need to do something else as well. Clear, yeah. A lot of these are going to be quite different, but I think this will work out in the end. He's okay, yes, it's great now for 2D games, but for 3D it has a long way though. Yeah, definitely, but I mean, some of the 3D stuff I'm starting to see come from Godot is really impressive. It's really starting to become a good option as a game engine, right? AM, you didn't know what pointers were. I did. I'm pretty sure I did. Okay. So unfortunately, I won't have the time to try this today because I need to run. Been going close to 6 hours soon. But it's probably something like this we're gonna have to do. We're probably gonna end up with a better approach later down the road. yeah, we can probably wait with creating this one as well until it's needed the first time, right? But yeah, I'm gonna have to leave on a little bit of a cliffhanger here, because I need to run. I don't know if I will be able to stream tomorrow, but I will. Best way is to just be on my Discord. I will post there. Otherwise, I will most likely be back on Wednesday. Hisoka, you too. Thank you for stopping by. Appreciate it. So thank you so much for watching, everybody. Appreciate it. And hopefully I will see you later this week. Have a beautiful rest of this Monday. Peace.